This is a talk about inventing tips. I feel qualified to give it after having hundreds of granted US patents. So I'll be talking, I'll say a little bit about myself. I'll explain some mistakes I made, and please don't make them yourself, no reason to. And then I'll start working with the tips. The first one is to use what it is that you know. Knowledge which seems to be outside the domain usually is very useful, and what you understand is similar to what you know. We'll talk about that. And then we'll talk about why it's very useful to invent problems, because it's the easiest way to get to good patents. We'll talk about how to use magic. It's not quite magic, but you know, the world is changing, and augmented reality and artificial intelligence are sort of like magic. And we'll talk about how to use them in inventions, which is a new concept, maybe less than 10 years old. And we'll talk about the biggest barrier for people from inventing, which is having a solution. When you have a solution, you can't get to a better solution, and that usually stops you from inventing. So I did my PhD in Carnegie Mellon. My advisor was Mike Drick and Herb Simon, who has won the Nobel Prize and the Turing Award. A very impressive person. And then I started in IBM research, and I became an IBM master inventor. And my field of work was software engineering. About 50% of my inventions were in software engineering, and 50% were in totally random ideas, which are not related to my field. My work as a master inventor was to help people invent better, so people would come to me twice a week, and I would invent for them. And I would help them with their inventions. And then in 2010, I quit IBM, and I had no specific plan of what to do next. And people suggested that I'll become an inventor for hire. So what I do is companies hire me. Some of them are startups, some of them are much bigger companies, and I invent for them. I already sold about 60 ideas. Some of them I will show here in this talk, and I have 175 granted USA patents. I help clients invent. So usually I would come to them, or they're brainstorming. The result of the brainstorming will be an invention, and I will be working on the lawyers to write it for the client. I'm not a lawyer myself. And I also help with patent strategy. After being in the field for a long time, I picked up some of the few things. And some people come to me and ask me for an idea for their next startup. Some startups started also this way. So my first invention was in about 20 years ago, 30 years ago, actually. Yeah, 30 years ago. And I invented a way to invisibly print something. This was while being in Carnegie Mellon University. And the university decided that this idea had no value. So I pursued it myself, and I made many mistakes, both legal and business mistakes. And this is because it was my first inventions, and because I didn't take the course that I will be teaching later about how not to take those kind of mistakes, not to make those kind of mistakes. And today, every good printer that you're using invisible printing, using my patent. The USA made them do that. So the entire industry is doing it. And the value is extremely high of the patent, but because of all those mistakes, I got very little out of it. So now I'll describe, we'll start with the inventing tips and use what you know. Okay, so I quit IBM in 2010, and I want to become an inventor. And a company called Intellectual Ventures is willing, already actually pays me for my next 10 inventions before I actually made them. So now I have to invent something. And I want to invent something not related to my previous job because I was an IBM master inventor. So I have to think of something else. So I'm thinking I have two hobbies that maybe I'll invent something related to them. One of them is learning about Judaism, and I didn't invent anything there. But another one is related to dancing. I like social dancing. I like Argentine tango, and I'm thinking about what is it that I know about tango. I mean, what is it I know how to do when I dance tango, and what I know how to do is I know how to lead. Okay, so I know how to lead, and how is this useful? And if you think about it, leading is useful for blind people. Blind people have two concepts which have been used for maybe 100 years. One of them is the stick, and there are also other devices. And those devices help the blind person figure out what's around them. And it actually turns out to be very difficult to do, even with the most amazing technology we have now. The second one is the dog. And the dog is a totally different concept. It takes you where it is that you want to go. It's a very well-trained dog. And you can tell him, take me to the supermarket. And if he knows where the supermarket is, he will take you to the supermarket, or you can tell him, take me to Chaim. And then you walk around and you hold the structures that is on the dog, and he leads you there. And I figured I know how to lead, and I know how to lead actually better because I'm doing it in dancing. So when I was talking to people who were training those dogs, I said I could teach the dogs how to lead large steps. And a large step is actually very useful because instead of going around the banana, you might not have space, you can go over it. But they didn't take me seriously, and they said I'm trying to teach the dogs how to dance tango. So this didn't quite work. So the Japanese people came up with this robot that is sort of like a dog for blind people. And the advantage of a robot over a dog is that you can tell him, take me to a specific address, and then it would consult the GPS and will look at all sorts of ways like algorithms, and will take you to that address. So, and a dog, as smart as it is, doesn't know how to read a map. But if you think about it, it actually makes no sense. So this robot is really expensive, and you don't need the robot. You just need to guide the person. I mean, you need the sensors which are on the robot, but they are not very heavy and not very expensive. You can put them on the person. You can put something here on the chest, maybe. And you can put your phone looking forward, and then you have all the sensors that you need. And now you need to guide the person. So what I did was I figured out guiding, which is sort of like in tango, and it was based on a belt which is on you, and it has actuators on it which can vibrate and tell you how to walk. And because we used it based on, it doesn't show only direction, like a leading dog does, but you can also pivot and do other things. We were good enough that with these directions we could take a person and walk in a restaurant. And also we could control the hands, not only the legs. So we could, if you think about it, you're in a restaurant and your sensor saw that there is a glass next to you, and you want to get your hand to the glass. So you put your hand up, and it would move your hand forward, down, sideways, and then to the glass, and then you can hold it. So you can do all those things with the sensors, and the hard part is understanding the environment, but this is done by the people who helps with the robots, who make the robots. And the easier part, which is what I invented, was how to guide the hands and the legs based on things that I knew from dancing. Another thing, okay, so you're in a party, an Argentine tango party. It's called a milonga. This is an image I took a picture I took in Buenos Aires. And you want to invite a woman to dance. And the way you do it is you try to catch her eye. And if you catch her eye and hold it for a few seconds, then you nod your head. And if she nods her head, then then you sort of agreed. She can be pretty far away, but you sort of agreed that you invite her and you walk to her and you start dancing together. Actually, a lot more complicated than that, but that's the basic idea. Okay, so I learned about that and I try to do that. It's not all that easy. And how is it related to technology? So I'm sitting there and doing the carousel and thinking, what can I do with it? And let's assume that you have an augmented reality glasses, and the glass knows where you're looking. It has to know where you're looking because when it adds information, it has to know what you're looking at to add the right information to the image. So if a few people have augmented reality glasses and two of them are looking at each other, say in a party, they can't talk because they are 3 meters apart and it's too loud. If they're looking at each other, their glasses know that they're looking at each other. And if they're doing the carousel, basically looking at each other for more than 2 seconds, then what the glasses can do is open a phone call between them. And this way you can start talking to somebody you have never met before, which is not right next to you, by just you two looking at each other, and a phone call will be initiated between you two. Okay, so those were about things that I do as a hobby, but sometimes you just, you look around the world and you learn something new and you figure you might be able to use it in a different setting. So for example, one day I was reading this news article and it was about how do you keep inspector vigilant in the airport. So the problem is the following. Your job is to look at the screen and to find out if there is a gun maybe or a bomb in the bags that goes through the machine. And what happens if you don't look? Well, generally nothing happens because most people don't have bombs or guns. And even if people do have guns, they try to smuggle them and not to take down the airplane. So basically, if you're not vigilant, nothing is likely to happen to you. Which means if there is no consequence for not doing your work, it's quite likely that you will not be as vigilant as you should be. So this company came up with the following idea. What they do is every 10 or 20 bags, they would add a gun or a bomb into the image, or a knife into the image, not into the bag itself, but into the image that you're looking at. And then if you don't spot it, your inspector would come and say you're not vigilant because he will be told by the machine that you haven't spotted the gun. And if you do spot a gun, there is a button that you press and you ask, is there really a gun there? And it either fixes the image to remove the gun, or which was added, or it doesn't, and then there is a gun there. And because every 20 bags there's going to be a gun or a knife or something in the bags that shouldn't be, this will keep you vigilant. I thought, oh, okay, this is really a nice idea. How can I use it? And I thought I could use it for reviews. One of the techniques for reviews is that somebody asks you a question about what it is that you have written as a code. And what about the computer asking you a question? That's not a problem. The computer can ask you a question. And he will ask question, did you mean that? Can you say that? And what we need to do is ask questions that the answer for them is a no. So you can't just say yes, 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 yes on everything. So a little bit more complicated than that, but I look at an idea in one field and I was able to move it to another field. Another thing is, another idea came from testing. So you watch a football game, like some of us do nowadays with the World Cup. And you want to tell the players what to do. You're watching it on TV, so you shout at them loudly. And sometimes they ignore you even though you have excellent ideas. So how could you tell the players what to do and have them not ignore you and see how good your ideas are? So the idea was that when you look at a game and you want to tell a player what to do, then you press a button on the remote control and you see the game twice. Nothing special about it so far. You just see the game twice. But when you want to actually tell him what to do, you press another button, and one of the games become a computer game where all the players are in the same situation as in the real game, including the ball and the referee. And there, because it's a computer game, you can tell the player what to do. And let's say the right is a computer game, and you tell Messi what to do. And after a while, those two games have nothing in common because you've been playing Messi here, and the real Messi have been playing there as well as all the real players. So after 30 seconds, you can go back to continue watching the real games. And in the end, you can ask yourself, or the game will tell you which was better, your Messi or the real Messi. When I gave an interview in Buenos Aires, the headlines of the interview was Shmuel Ur, the Israeli scientist who can control the movement of Lionel Messi. So they thought this would sell in the newspaper. The easiest way to come up with new solutions is to invent problems. And the reason it is the easiest way to come up with new solutions, and actually not only the easiest, but the most valuable, most profitable, is because if you invent the problem, you are the first to solve it, so you don't have a competition. And there are lots of smart people out there. So if you are the first one to see a problem, that's really good for you. So 8 years ago, I've been thinking about what will be an augmented reality skin shop. So on the phone, we have a store with all the apps that we can download, a few millions of them. And let's assume that you have an augmented reality glasses, and there'll be lots of apps for the augmented reality reality glasses, and they will be on the store. And the question is, how will the store work? The difference between a store for augmented reality apps, which I call skins, is that they're not independent. They must work together. They work on the same screen. They share a screen. So it's not like you can do one without the other. So the situation we're talking about is people have augmented reality glasses, like now they have phones, and they have lots of skins which are always active. And skins may complement each other. They may look at what the other skin did. And the order is important. So for example, if you have a skin that change a dog to a cat, and you have another skin that change a cat to a green cat, then the order is important, because if you do it first, change the dog to a cat, and then the cat to a green cat, you change the dog to green cats. But if first you change the cat to a green cat, but there's a dog there, then the skin did nothing, and then the dog is changed into a cat. So the order is important, and it actually makes no sense to ask the people in which order they want the skins. They have 150 skins that they downloaded, and you ask them what order they want the skins to be, and they don't know how to answer that. So a skin store is not like an app store. It's a different thing. It's a different concept, and it has different issues, different problems. So you need to figure out which order it is, and you need to help people. When you get a new skin, you need to figure out where to put it in the order, and you need to be able to help them with that. The skins, all of them have to work in about 1/20th of a second, otherwise they cause a headache. So it's a lot of computation power, and what happens if you don't have enough computation power to do it in 1/20th of a second, and you have 30 skins? You need to choose which of those skins to use. You can't do all of them just because you don't have the computation power. You want to be able to run the skins efficiently. So if you have multiple skins that are working on cats, you don't want each of them to find cats in the picture. That's intensive, computationally intensive. You want your framework to find the cat and the skin to work only if there is a cat, so it will be much more efficient. There'll be bugs in the skins, and those bugs sometimes happen in the real world. So how do you test and debug? And do you have a language for non-programmers to write skins? All sorts of issues for that. So I looked at all those issues, and I figured out what the problems are, and I solved them. And then, I solved 4 inventions based on those solutions. So now let's assume this world exists and you have an AR, you have an augmented reality glasses, and the skins are really well done. So you don't know if I'm here or not here. I might be part of the skin. You don't know the difference. I mean, it looks real. Can you drive with the AR off? So the problem is that you have some of those skins are killer apps. So your navigation is maybe a horse that you're chasing on the road. So without it, how would you navigate? And you have all sorts of information. People stop putting signs there because they know they have glasses, and their glasses will show you the signs. Those are apps that you need, and apps that you like, and apps that you must have. And how would you drive without it? But is it safe to drive with your AR on? Could be the problems if you drive with AR on. What happens if some of the apps are malicious? So let's assume that there is an app that raise kids that run into the road in your street, only in your street because it was done to attack you. Would you feel safe driving knowing that an app that you downloaded that, you know, for whatever reason also does that? It might do that, you don't know. It could show an imaginary kid or a dog running into the road, and then you have an accident because you jump, your car jumps, and those are attacks. And when attacks are possible, people do them. So you need to defend yourself somehow. And it could be that it's just a bug. So for example, you decided that today you like to drive on a green road. And the road had a pothole in it. And it was covered with grass. So you don't see the pothole, and you ride right next to it. So how do you protect yourself? I'm not going to reply to that, but the big issue here is the question. So there is a problem, right? We have apps, and if we have apps, they can attack us, they can attack our minds, they can attack our driving. And how do we protect yourself? And once we have a question, usually we can find an answer. And being the first one to see the question, our answer is patentable. Okay, so now we got to the use magic part. And it used to be that to write a patent, well, it still is the case that to write a patent, you have to explain how it is done so somebody else can do it. But now artificial intelligence is out there, and you can just say, and then I use artificial intelligence and it works. So I'll give an example from eye tracking patents, of which I have quite a few. And notice that when you look at somebody's eyes, you can learn something about them. And most people are not very well trained in controlling the eye movement. Actually, I don't know anybody who's trained in controlling the eye movements. So I was asked the following question. Somebody asked me to, one of the first assignment I had was to find people who lie in the airport. And I couldn't find people who lie because that's a hard problem. People always look for people who lie. So I thought maybe what I can find, because I've read some articles in psychology paper, was I can find if you look at somebody and I watch your eyes, I can see if you know them or don't know them. And the way I can do it is there was research that showed that if you know the person, you look on the inside of the face, and if you don't know the person, you look on the outside of the face. And then I said, well, I'll show you a face, I'll see where your eyes are looking, and I will show if you know him or not know him, and that's useful for interrogation. So we had the startup was starting based on this idea, and they built a machine and they did the experiment, and it just didn't work. We couldn't replicate it. And a few years later actually came a set of papers that said that nobody was able to replicate it. It's just not true. Because when you look at a person, you look at him, you look at each person in the same way. For each person, it could be different how you look at somebody, but it's always the same way. So it's left eye, right eye, mouse. It could be for somebody else, right eye, left eye, mouse. But you look at all the people in the same way to identify them. Okay, so this didn't work, so I had to find a different way. And the way I came up with is the following. I show you two people and I ask you if it's the same person. So there are two options. Either you know them or you don't know them. That's one question. And the second one is, do you lie or tell the truth? So let's assume to begin with that you tell the truth. If you know them, you look at the one to the right and the one to the left, and you say the one to the right is Chaim and the one to the left is not Chaim, and that's it. So you look once here and once there. If you don't know them, and they look sort of similar, what you do is you look at the feature of the face and you jump between them. So looking at your eyes, it's very easy to see if you know them or don't know them, if you're not trying to lie, because in one case you just look at one, and then the second, and in the other one you jump from one to the other all the time between similar features. But you're actually interested in people that are trying to lie. So one option is that you say you don't know them, but you say that you know them. That's not an interesting option because they can ask you who it is and you don't know. But the interesting lie is that you know them and you're trying to look as if you don't know them. So what you do is you jump between the faces and you try to solve the problem as if you don't know the person. And now comes the question is, can you control your eye movements in the same way to look as if somebody who doesn't know? And here comes the magic. What I do is I will give the task to people who know and the people who don't know. And then I will collect the data and I will use clustering and machine learning, and I can create categories of those that know and those that don't know. And it turns out that those categories are different. And machine learning solved the problem for me. And now I can tell if you're lying or not lying. And what I did was I said I use machine learning and clustering. Previously, I had to actually create an algorithm that would do that. And that was very difficult. So now I don't have to do the algorithm anymore. I say I'm using machine learning, and that's totally permissible. Here is another problem. A company comes to me and they want a patent in the area of remote learning. This was 7 years ago, before Corona, but of course became more important with Corona. And the issue is, it's MIT is teaching somebody and he's in Tanzania and he's taking the class in Zoom. And the questions that I had was, that I was thinking of is, when you do an exam in Zoom, what they do is they actually measure that it is you. That's not hard. They have a camera, it's looking at you, they know your face. Okay, so you're doing the exam. But how do they know that you're solving the problem and it's not anybody that sitting next to you telling you what to write? So what they do is they put the camera and try to look if there's somebody in the room, but it's very difficult. I mean, it's your room and you can put somebody right next to your feet or something. So what I want to know is it you that is thinking about the result? And how can I know that? So again, I'm going to use magic. What I'm going to do is I'm going to show the exam to people who know the result and people who don't know the result. And I'm going to look at their eyes. And the people who know the results actually care about specific piece of data and they will look at them more. And people who don't know the result would look at different things. So what I can find out is if you actually truly understand the question by looking at your eyes. And if your eyes doesn't show me that you understand the questions, then I don't know that you cheated. Maybe you have an eye condition like nystagmus, or maybe you think totally different than other people. But what I will do is, for those people that the eyes show pattern of people that don't know the answer, however, they did know the answer, I will test them again in a place where somebody is looking at them. So this enables me, this idea, and again, using clustering in AI, I don't have to provide the algorithm. The algorithm is magic. I put it into 2 classes and now it's done. And now I can test remotely, and people that don't look like they understand the problem will have to be tested separately. So the next thing I'm going to talk about, which is my last hint, is that when you have a solution, Don't be happy with it. Ask what's wrong with my solution. So the problems that I was looking at was I have a drone and I want to do a delivery. And let's say I want to send a drone I want to send something 40 kilometers away, and 40 kilometers is longer than a drone can move for all sorts of reasons. The range is probably about 10 to 15 kilometers, or maybe 10 miles for those who think in miles. So how would a drone get there? So it can hitch a ride. This is what I thought. And what I would do is I would hire buses and trucks, and I would put drone landing pads on them, and I would connect it with GPS. In the same way, when you say you want yourself to go, and they tell you where the bus is and stuff, and you walk to the bus, step on the bus, you continue, and you walk to your destination. This will be with the drone. The drone will ask the central agency where there is somebody going in his direction. It will wait, and then when the truck comes along, if it's empty and he's told he can jump on it, he jumps on it. He gets some energy from the truck. He moves those 10, 15, 20 kilometers and continue to his destination. So if you do something like that, you can send drones to distances which are not very close. So this was I thought this was nice, but in order to continue to invent, I said you have to ask what's wrong with this solution. So what happens if you're going long distance? It's a waste. I mean, let's say you want to send something from Chicago to New York. That's a long distance, and if the drone goes all the way, you wasted the time of the drone going all the way, and you actually want to send the package, not the drone. So what can you do that? How can you improve the solution? So what you can do is on some ducts you can put sort of a vending machine for packets, and the drone will bring, and those are for the long distance one. And then the drone will bring it, and then the truck would go from, say, Chicago to New York. So if you want to send something from Chicago to New York, you send the drone to the highway, and the drone finds the trucks going in the right way, and it puts the bag on it, goes back to wherever it was doing. And then the truck drives for a day or two or half a day, doesn't matter, I mean, pretty far. And when it gets to the place, another drone would come and pick up the bag for delivery. And of course, there are issues with this solution as well that you have to solve. But this shows you, and I can give many examples, that something that usually really stops people from inventing is having a solution. Try to figure out what's wrong with your solution and then solve it. And the second solution might be new. The reason the second solution is better than the first solution is there are lots of smart people in the world, and the first solution is usually obvious to most people. The second solution is a lot less so. So if you go second, third, you might come up with something new and something valuable. Hope this was interesting. And well, I guess that's it.